for problem I. Now let's look at J. In J we have a 3a squared times negative 5 to a to the negative 6 and a negative 2a to the 0. Let's go after our special case first, which is when we take anything and raise it to the 0 power. When we have an entire piece raised to the 0 power, the entire thing turns into a 1. So that means that this whole thing is just like multiplying by a 1. The whole thing is just going to vanish. So that leaves us with the 3a squared and the times negative 5a to the negative 6. Okay, well, let's see what else we have then. Then we're just multiplying regular numbers because there's no exponents. We've got a 3 times a negative 5. Well, 3 times a negative 5 is negative 15. Okay, what else do I have? I have some a's in here. I have an a squared and an a to the negative 6. I can do one of two things. I think the easiest is to leave the a squared where it is because it's got a positive exponent, and to drop the a to the negative 6th exponent down to the denominator, and then that negative 6 will become a positive 6. Then I can either use my subtraction rule or I can cancel. I can cancel out some a's or I can subtract. If I subtract my exponents, be careful, 2 minus 6 is a negative 4. So I'll end up with a negative 15, a to the negative 4. But then you wouldn't be allowed to leave your answer like that. You'd have to drop your a back down to the denominator because you can't leave your answer with a negative exponent. And then the exponent would become positive. And then you've got negative 15 over a to the 4th. Now just to kind of point this out, you could have just at the top step just realized you're multiplying, so you're adding exponents and done 2 plus a negative 6, which would also get you a negative 4. That's another way to do the same problem. Or one last option would have been to cancel out the 2 a's on top with 2 out of the 6, which would leave you with 4 of the a's already just on the bottom. So any of these three methods will get you the negative 15 over a to the 4th. Notice the negative 15 stays on top because it doesn't have a negative exponent. The only things that should ever be moving from either the top to the bottom or the bottom to the top is if it has a negative exponent. Not if it's just a normal negative number, then it stays put. Let's take a look at K. In problem K, let's see, we've got m to the 4th, which is then raised to the 0 power over 9m to the negative 3rd. So let's deal with the top first. We just did something similar to this. Anything, whether it's m to the 4th or not, raised to the 0. Remember, anything raised to the 0 just turns into a 1. So the entire numerator, the entire top of the fraction just turns into a 1. We still have the 9m to the negative 3rd on the bottom. Now what? Now we can deal with our negative exponent. Well, our negative exponent is already on the bottom. So to get rid of the negative exponent, where can we move it? Well, the only place left to move it is to the top. So the 1's going to stay where it is. The 9's going to stay where it is because they don't have negative exponents. However, the m to the negative 3rd is going to move to the top. When it does, the negative exponent becomes a positive exponent. So I get the m cubed on top. Now, however, this 1 out in front of my m cubed doesn't need to be there anymore if the m cubed is going to be on top. So I can rewrite this one of two ways. I can rewrite this as 1/9 m cubed, or I can write it as an m cubed over 9. Either way, either one of these answers will work. Let's take a look at L. On problem L, we have 2 times, with the parentheses, m to the negative first to the negative fourth, all over 9 m to the negative third squared. Well, the first thing we want to deal is with our parentheses. We've got a power to a power, which means those parentheses are a reminder that I'm going to be multiplying my exponents. The 2 is out in front, so it's nice and safe. It's not going to get touched at all. Same thing with the 9. So those will just remain the same. They're out in front. They're not affected by the exponents. But the m will become, well, negative 1 times negative 4 is just a positive 4. And on the bottom, we have an m to the, we've got a negative 3 times a 2, which will get us negative 6. Now, the only thing that needs to be really tampered with is our negative exponent on the bottom. That's the only one that needs to be moved. Well, if it's got a negative exponent and it's on the bottom, the only place for it to move is up on top. So it'll become an m to the positive 6 when it gets moved up on top. So that gives me a 2 on top still, a 9 on the bottom still, but now I have an m to the fourth and an m to the 6th up top. So what do I do now that I'm multiplying these two instead of dividing? Well, remember, when I'm multiplying, I just need to do what's the exponents I need to add. I've got 4 m's added to another 6 m's is a total of 10 m's. So that's m to the 10th. So I can write this kind of the way I have it, as 2m to the 10th over 9, or I can write it as 2/9 m to the 10th. Because remember, if you see a variable off to the side of a fraction, it's understood that if you were to write it as part of the fraction, it would automatically be on top of the fraction. And that's our final. Now let's take a look at problem M. Let's see, on M, we have, negative 4, x to the 4th, y to the 4th, z to the negative 2nd, all over a 2x squared, y to the 10th, z to the 4th, and then squared. Now, order of operations is always going to tell us to do what's inside of the parentheses first. So the question should be, can I make what's inside of the parentheses better first before I even mention touching that exponent on the outside? So let's take a look. So let's see what we can simplify first inside of those parentheses. So we will leave the exponent, the squared, on the outside, and let's see what we can reduce or simplify on the inside. Well, the first thing that we have is a negative 4 divided by 2. That's a normal fraction. Those are both divisible by 2. So that will reduce to a negative 2 over 1. So far, so good. The next thing we can reduce is the x to the 4th over the x squared. You can either subtract the exponents and do the 4 minus 2, or you can cancel out the x squared, 2 of the x's, with 2 out of 4, which will leave you with the extra 2 x's on top. Had you subtracted exponents, you would have done 4 minus 2, which is 2. You would have still gotten a positive 2, which would have put an x squared on top. Now you'd go after your y's. We've got a y to the 4th on top and a y to the 10th on the bottom. So if you subtracted your exponents, you would get a negative 6, and then you'd have to drop your y to the negative 6 to the bottom. Or you can just cancel out the 4 y's on top with 4 out of the 10 on the bottom, which does leave you with your leftover 6 y's on the bottom automatically. Okay, z's are a tiny bit, and I do mean just a tiny bit more complicated, and that's because I have a negative exponent of z to the negative 2nd, so it's probably just easier just to move that guy down with my z to the 4th. That will make my exponent positive. But then that gives me a z to the fourth and a z squared on the bottom, which can then be put together and just add it up. So 4 z's and 2 z's on the bottom means I've got a total of 6 z's on the bottom. Almost done. Notice I do not need to write that 1 in front of the y to the 6 and z to the 6 on the bottom because it's not there by itself. So now what I have is a negative 2x squared on top and a y to the 6 and a z to the 6 on the bottom, and then this whole thing is squared. So the only thing now I need to deal with is this squared on the outside, which means be careful that I need to square each and every piece on the inside, one thing at a time. So first of all, I need to square the 2. Sorry, it's a negative 2. So that means I need to square a negative 2, which means a negative 2 times a negative 2, which becomes a positive 4. Next thing I would want to go after is squaring my x squared. Remember, you multiply exponents, so that would get me an x to the fourth. And I'd have to square the y to the 6, which again, multiplying the exponents will get me a y to the 12th. Same thing with the z to the 6, raising that to the second power. Again, multiplying the exponents will get me z to the 12th. So my final answer for m is going to be this 4x to the 4th, y to the 12th, z to the 12th. Notice anything that's left over, there are no matching variables, so I can't reduce that anymore. But I'm done.